For number 16, there's something in here that if you watched or read anything about the problem, and that was kind of the idea. It was a bit of a stretch, and sorry if that threw you off a little bit. But you do need to go back in the old annals of things we did a while ago. Profit is revenue minus cost. And if you're looking for and the first question I think in 16 is what's the profit function? So you just have to put revenue in. So this 1 over 20,000 you got right here, and then the 61,000 x minus x squared, there's your revenue, and then minus the cost function. The biggest error I'm running into is you're forgetting to put the cost function in parentheses, because you really do need that. So plus 730, ooh, 00, I can write, I promise I can work this out. So there's your revenue minus cost. If you don't put the parentheses around cost function, it'll fail to distribute that negative properly. If you decide to get rid of the parentheses, just make sure you make that negative 0.9x and minus 7,300 before you do so. But that's it, that's the first part. Then of course it asks you for intervals of increase and decrease, which means we need to find the derivative, find its critical values, which are only from the derivative being equal to 0. So I'm just going to take this particular problem, I'm going to copy and paste all this onto another page here so I can just use it again since I wrote it so nicely. And we'll be ready to go. So I'm going to add a page. Let's do this. We can undo and paste. Bingo, got it. Looks like we got everything we need. Now P prime then is you take the derivative of these. Now if you think about, there's something about derivatives that we'll get to later. It's called the constant multiplier rule, and it's that this number here can actually tag along. We can just do the derivative of what's inside the parentheses here and then just stick the 1 over 20,000 on afterward. And so that's what I'm going to do. You can also distribute it in there, multiply it through, and then take the derivative, and you'd be fine as well. But I wanted to show you that constant multiplier rule just to give you an idea that it does exist there. So let's look at this derivative. If I just take the derivative of 6100x minus 2x, sorry, 61,000, that's 61,000, the derivative of 61,000x minus 2x, the derivative of x squared, and then we just get to put that 1 over 20,000 right back out front there. No harm done. Okay, nice easy derivative. The second one, we can just do the derivative inside there as well. The derivative of 0.9x plus 7,300, that's just 0.9. Done. So there's our derivative. If you want to find the intervals of increase and decrease, you will want the critical values. So you want to set this thing equal to 0. Maybe I'll just make just enough room that I can, fit an equals 0 on the end there, which saves me a little bit of trouble. And we can go about our process of solving, which add 0.9 to both sides, and we'll get rocking this thing. So I'll just do a few steps along the way. Let me just show you. I'm going to highlight them. I'm going to add both the 0.9 to the right, okay, and then I'm going to multiply both sides by 20,000 to get rid of that. So see if you can follow these algebra steps kind of at once, because I think you're ready for that push where you really do have to have your algebra in your back pocket in some sense. 0.9. And remember, I multiplied both sides then by the 20,000, so we had the 20,000 over here. Remember, I'm doing opposites. I'm undoing. So adding 0.9 and multiplying by 20,000 are ways of getting rid of those things that I've highlighted in green up there. Next, you're subtracting 61,000 and dividing by negative 2. So I'm going to subtract 61,000 from both sides, and then I'll divide both sides by negative 2, and we're going to get x alone. I'm going to do those things and just let you do the mathematics, see if you can figure it out. But I'll just write the results here so that we can move ahead. And so you get 21,500. Okay, that's our one critical value that goes for this. And if you go graph this profit function, it's a quadratic. It's x squared, so it's kind of an upside down parabola. So that critical value is indicating a peak in here. So this 21,500 indicates a peak or a maximization of our profit, which is awesome. That's something we're going to really start talking about in the next couple classes, so get ready for that. So if I imagine there's this parabola and I just found out, hey, at 21,500 units, or whatever it indicates, my profit is maximized. So it says, I think one of the questions is, when do you want to, what number of units you want to set it at? Well, if we're going to set a peak, this is the place, that's what you want to input. The interval of increase that goes with that, the increase is on the left, and it may have a specific domain, and I'll have to look back. I don't know if this problem had a restricted domain or Maybe I'm missing something. Oh, it was 0 to 50,000. Okay, so we want to make sure we accommodate that. So when I say the interval of increase, it's going to be from 0 to my peak of 21,500, and then it's going to decrease then on the other side of that, but it doesn't go forever. It's from 21,500 then to 50,000, and you stop. And there's your decrease. And so the rest I'll let you kind of figure out, but that's a good start.